All right, I'm going to be a little squeezed for space here, it looks like. Mr. Kaiser had a good summer. He won the lottery, $40,000. So he's got $40,000 to invest. Okay? He invested some of the money in a savings account, earning 4%, and the remainder in stocks that he hoped would earn 6% annually. Mr. Kaiser wants to use the earnings to pay the cost of his $2,040 trip to the Ironman Triathlon in Maui. How much should he invest at each rate? And I've taken the liberty to set up a table to assist you in writing the equation. So we're going to set up a table, and we have the dollar amount, and the interest rate gives us our total income. So how much we invest at a particular rate will generate some income for us. And in these tables, generally, we multiply across, and we add down. So let's go ahead and include some labels here. Okay, so let's say he's going to put some money in savings, and he's going to put some money in stocks, and he's got his total amount. Well, his total amount that he's investing is $40,000. So how much is he going to put into his savings? Well, that's a really good question. We don't know that. In fact, we don't know how much he's going to put in stocks either. So let's say we'll put X amount in stocks. So the rest of it goes in savings. So if we put $1 in stocks, that would be $39,999. Or if we put $10,000 in stocks, well, 40 minus 10 is 30. So if we put X amount in stocks, the amount in savings is 40,000 minus X. It's whatever's left over. Okay? The savings rate is 4%. The stocks rate is 6%. We aren't going to have an overall rate. We're not going to use that particular cell. So we multiply across. So we have 0.04 times 40,000 minus X. Don't distribute this right now, just leave it. And this is 0.06 X. And our total income, well, we multiply across, but we don't have anything to multiply in this particular cell. But our total income was $2,040. That's how much money he needs to go to the Ironman. So, $2,040. And as it turns out, here is our equation. All we have to do is add this column. Okay? So, by adding this up, we have 0.04 times 40,000 minus X plus 0.06 X equals our total income. So our income from our savings plus our income from our stocks equals our total income, $2,040. Okay? We're going to multiply by 100 to get rid of the decimals. So we have 4 times 40,000 minus X plus 6X equals 2040, and we multiplied that by 100, so that's 204,000. Distribute the 4, and we get 160,000 minus 4X plus 6X equals 204,000. Combining our like terms and subtracting 160 from both sides, so we get 2X equals a total of 44,000. So X equals 22,000. We go back to our table, and X was the dollar amount you invested in stocks. So 22,000 in stocks. And since we only had 40,000 to begin with, that must mean that we have another $18,000 in savings. So that's how he's got to divvy up his lottery winnings. So Mr. Kaiser can use his just the principal and then spend the interest on his trip to the Ironman triathlon. Congratulations, Mr. Kaiser. Problem number 5, another table problem. Mrs. Lemminger is mixing 8 liters of a 40% acid solution with some 70% solution to get a 50% solution. How much should be used? How much of the 70% solution should be used to get a 50% solution? So let's take a look at this. We have amounts and rates and totals again. We're going to multiply across. We're going to add down. So what goes here? Well, don't we have a 40% acid solution? So we've got something that's 40% acid. In fact, we have 8 liters of 40% acid. Okay. The question is, how much 70% acid should be added? Well, how much is, we don't know. That's X. So 70% acid is 0.7. And then we want a final solution that's 50%. So I'll just call this, the final. And we want that to be 50%. So we add down, so the final solution is going to be what we began with, the 8 plus whatever we add. And we multiply across. So we have 0.4 times 8 and 0.7 times x and 0.5 times 8 plus x. So once again, this is going to be our equation where we have 0.4 times 8 plus 0.7 times x equals 0.5 times 8 plus x. I'm going to go ahead and multiply all of this by 10 to get rid of the decimal. I'm going to multiply everything by 10 and get 4 times 8 plus 7 times x equals 5 times 8 plus x. So I get 32 plus 7x equals 40 plus 5x. I distributed the 5. I'm going to subtract 5x from both sides. And I'm going to subtract 32 from both sides. And I will get 2x equals 8. So 2x equals 8. Then I know x equals 4 dividing by 2. So apparently I have to add 4 liters of 70% solution. And we've answered the question. All right, and on to our final word problem in applying linear equations. Another percent problem, a solution problem, but this time we're working with pure solution, okay, or a pure acid, as you will. So it says the octane rating of gasoline is a measure of its anti-knock qualities. For a standard fuel, the octane rating is the percent of isooctane. So when you go to the gas station and you fill up with 87 octane, that means the fuel is 87% isooctane. So a word problem. How many liters of pure isooctane should be mixed with 200 liters of 94% isooctane, or 94 octane, to get a mixture that is 98% isooctane? So what percent is pure isooctane? Well, hopefully you know that that is 100%. So set up a table and let's write an equation here. So we've got a couple things. We've got some 94% isooctane. We've got some pure isooctane, and we want to end up with 98% at the end. So we're starting with 200 liters of 94%. So we can put 200 there. And the question is, how much pure isooctane should we add? So that's our unknown. That's X. Okay? And 0.94 for that. And that's going to be 1.0. And we want 0.98 at the end. So we've got everything, a bunch of this filled out already. Now on our tables, we know we multiply across. We add down. So the total column here is going to be 0.94 times 200. And this is going to be simply 1x. And now we add down the amounts. The 98 is going to be the 200 plus whatever pure we add. So that's 200 plus x, which makes our total column 0.98 times 200 plus x. So now we can set up our equation. Our equation is the addition of the total column to our final total amount. So our equation is the amount of 94%, so 0.94 times 200 plus 1x equals 0.98 times 200 plus x. And I'm going to multiply all of this by 100 to get rid of the decimals, okay? And again, we don't multiply the 200 plus x by 100 because when we multiply the 0.98 times 100, that's going to take care of the 200 plus x. So we end up with just 94 times 200 plus 100x equals 98 times 200 plus x. 94 times 200, that's 18,800 plus 100x equals 98 times 200, that's 19,600 plus 98x. And I'm just going to take this and go back up here and rewrite all this. So let's try 18,800 plus 100x equals 19,600 plus 98x. All right. Do a little color change here. Little algebra, subtract the 98x from both sides. That's going to be easy. And subtract the 18,800 from both sides. And I get 2x equals, conveniently, 800. Divide by 2. X equals 400. And I look at my chart. That is the amount of pure isooctane. So 400 liters of pure isooctane is what we need to add to our 200 liters to get 98% isooctane. So a lot to digest there, a bunch of word problems. We'll go through more of this in class over the next couple days. So see you in class.